Hi everyone, and welcome to our last video for probability. And we're going to go through combinatorics in this one, or combinations. So this is where we've got possibilities and we want to select out of them how many possible combinations we could have. So up here I've got from your formula sheet the NCR, that is how we find the number of combinations. And you can see next to it the factorial, where n exclamation mark equals n times n minus 1 times n minus 2 times blah, 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 all the way down to 3, 2, 1. So a combination is a selection of objects where order is not important. So if the order is important, we're getting into what we call permutations, which we're going to do this year. It's not in the course, it's in methods 4, but we just don't have the time to do it. So we're going to do combinations, and if you continue on to methods 4, you'll see permutations next year. So order is not important. It doesn't matter who's in the first spot, the second spot, the third spot. It's just as a combination, how many combinations could there be? So n up there in the corner is the total. So if we're selecting from 9 people, that would be a 9, and R is the amount chosen. So if we're selecting 3 people from a group of 10, n would be 10, R would be 3. Right? So let's start off just with an example. So this has no theory, no question. This is just, can you use the formula to figure out the answer? And you will have questions like this in your assessments. So n is 10 here. We're picking out of a total of 10 options, and we want 3 of them. So I'm just going to copy my formula straight from here. So n factorial of 10 over the factorial of 3 times 10 minus 3. Okay, and then it's just a bit of simplifying from there, which hopefully you practice with the last lot. So we've got, I'll leave 10 there for a second, and that would be 7. So then I'm going to simplify a little bit. 10 times 9 times 8 times 7. Now I can cancel out here because this here is a multiplication. If there's an adding or a subtracting, sorry, on the bottom or the top, if there's more than one term, you can't just knock out terms right and center, okay? You fools and puppies. Okay, so we've got 10 times 9 times 8, which would be much to do in my head. Over 6. And I'm going to keep going because I didn't bring my calculator home with me. Okay, so the number of possible combinations, if we're trying to pick a group of 3 out of 10 possibilities, is 120 different combinations. Now that's one type of question you get, just a can you do this kind of question. A higher up question would be one like this. So a committee of 6 is to be formed from a group of 5 men and 4 women. Now it's a 2-part question, which is going to require 2 different calculations. Part A is how many committees can be formed, and part B is how many committees contain 3 men and 3 women. So let's start with the first one because the first one's the easiest. So we're going to write our notation. So we're looking for combination. We have got how many total? 5 men, 4 women. We're not worried about gender in the first one, so we've just got 9 total. And we want 6. Okay, so let's use our formula. I've already done it wrong. Okay. 3. And I'm going to knock out that 6. Okay, which gives me 9 times 8 times 7, which is 504 over 6. Okay, so 84 possible committees could be formed if we want a committee of 6 and we've got 9 options. There's 84 different options that we could have. Now, the second one takes a little bit more remembering, I guess, and the remembering comes from and. Okay, when you see and, we're going to be multiplying. Okay, and I'll show you what I mean by that. So how many committees contain 3 men and 3 women? So our committee, our combination now, we want out of the men, so we want 3 men, and we've got a total of 5 men. And when we're talking about the women, we want 3 women out of 4. Now that word and means that we're going to multiply these probabilities. Okay, if you think back to say the tree diagram, what's the possibility of rolling 1 and 2 and 3? We're looking at multiplying through those probabilities. So same as in this one, we're going to multiply them, and that just means we're going to have a couple more steps. So we're going to start with the males. So 5 over, I'll just shortcut this one, times factorial of 4. Now, factorial of 1 is just 1, so we can kind of ignore that. We can go 5 times 4 times 3 times, this is the bonus of me being at home, you get Bamford making noises in the background. So we're just simplifying through here. So we've got 5 times 4, which is 20, over 2, which is 10, times 4. So there are 40 different committees that we could form that consist of 3 men and 3 women, okay, in any order. So if you've got that formula down, you should be pretty okay. Just remember that when you see the word and, we're multiplying through.